Okay, so today we're looking at lesson number 5, evaluating logarithms. We did this a little bit in the last lesson, and I'm going to try to make this a shorter video, so I'm going to go a little bit faster through the questions and some of the examples. So if we look at this first question, Kelsey was asked to evaluate log 2 of 8, and her work is shown below. So log 2 of 8, we want to find out what the value of that is. And so what we did was we represent log 2 of 8 with the unknown value of v. The next thing we need to do, well, if we look at what she did down here, she changed it to exponential form. So the next step would be to convert to exponential form, and that's where we get the 2v to the power of 8. Because remember, this argument becomes our value of x, and then v becomes our exponent, and 2, the base of our log, becomes the base of our exponent. Now what we need to do is convert to common base. So if we have 8 and if we have base 2, then the easiest thing to work with is another base 2. So convert to a common base. So these are the steps that we need to follow in order to solve our logarithm. Now we drop our bases, so we get rid of those, and we are left with v is equal to 3. And so we drop our bases, and we're left with our value of 3. And then we replace v with our initial equation of log 2 8. So replace v with equation. Alright, so we'll do 2 examples here. So evaluate the following logarithms. Remember, we need to set this equal to our value, or v, and the next thing we would have to do is set this equal to 81, and the 3 becomes our base, and so we're left with 3 to the power of v. Now what we need to do is we need to use a common base, and if I have 3 to the power of v, then the common base I'm going to use is 3. And if I were to have a value of 81, we know that that is equal to 3 to the power of 4, which is equal to 3 to the power of v. Drop our bases, we're left with v is equal to 4. Now I replace v with my equation, and so I'm going to be left with log 3 of 81 is equal to 4. Now let's do the next one. I'll skip this one, and I'll do C. So we set that equal to v, and we convert to exponential form. So I'm going to have 7 is equal to 7 to the power of v. Next thing I want to do is I have to convert to common bases. So this is going to be 7 to the power of 1 is equal to 7 to the power of v. Last thing I do is drop my bases. I'm left with v is equal to 1, or log 7 of 7 is equal to 1. Alright, so easy peasy. Now let's determine the value of log b of 1. Now we're going to do this the exact same way. Alright, we got to start by setting this equal to v. The next thing we want to do is set this to exponential form. So that becomes my x value, and this becomes b to the power of v. Now what I want to do is I want to set my bases so I have a common base. Now remember that anything that equals 1 actually has a power of 0. So we're going to use that rule, and that becomes b to the power of 0, because that is equal to 1, is equal to b to the power of v. Drop our bases, and in this case our base is b, so this becomes v is equal to 0, and then we replace the v with our original equation, and so I know that log b of 1 is equal to 0. Alright, and so we're going to do the same thing for this next question. Well, this next question, it's also going to equal 1, but I'll let you figure that one out. It's using the exact same method. Alright, I'm going to do A and C because those ones are probably the trickier ones. Well, actually, B and C are probably trickier, so let's see with B. So we begin by setting this equal to V. Using exponential form, we are going to rearrange this equation. Remember, that becomes my base, and this is my exponent. Now the next thing I want to do is I want to use the same base. So remember that 1 to the 32, 32 as a base 2 is 2 to the power of 5, but because I have 2 to the power of 5 on the bottom, it's still not quite what we want to work with. So let's rearrange this. So I have 2 to the power of negative 5 is equal to v, and we get our drop our bases, we get v is equal to negative 5, and then replace that. Log 2 of 1 divided by 32 is equal to negative 5. And this next one, we'll begin by setting this equal to v, and we're going to set this to exponential form. So I'm going to have 5 to the power of v, and I can refer this as 125 to the 1/2. That might be easier to think about. Is equal to 5 to the power of v. And if I were to simplify this even further, base 5, 5 to the power of 3 to the power of 1/2 is equal to 5 to the power of v. 3 times 1/2, we're going to be left with 3/2 is equal to 5 to the power of v. And if I drop my bases, v is equal to 3/2. And I replace that with my original equation. Log 5 of square root of 125 is equal to 3/2. Okay, the next thing we want to do is evaluate my equations here. We're going to do the exact same thing that we were doing before, but instead of simply just setting it equal to v, we're going to have to rearrange it a little bit. Okay, so in this case, I'm going to say that v is equal to log 5 of 25. And I'm just going to do this for simplicity. And so 5 is now equal to the power of v. And if I were to rearrange this into exponential form, 5 to the power of v is equal to 25. And I can reset this, so 5 to the power of v is equal to 5 squared. And now I have v is equal to 2 if I drop my bases. Now what we want to do is replace v with our original equation, which was log 5 of 25. So 5, instead of 5 to the power of v, it's 5 to the power of log 5 of 25 is equal to 5 squared, or 25. All right, so let's do another one of these questions. So 7 to the power of log 749. So we're going to let v equal, again, the exponent, log 7 of 49. Now, if I have 7 to the power of v, I can set that, we're going to use exponential form here. So 7 to the power of v is equal to 49. Because the 7 comes my base, that becomes my exponent. And now I'm left with something that I can put into a common base. So v is equal to, or 7 to the power of v is equal to 7 to the power of 2, which is the same thing as 49. And v is now equal to 2. And we're going to do the same thing and replace our bases. So 7 to the power of log 7 to the 49 is actually equal to 7 squared, or 49. So based on your observations from A and B, that's all. What is the value of a to the log a of n? Well, a to the power of log a of n, if we look at what happened here, well, that was 25 and that was 25. This was 49, this was 49. So a to the power of log a to the n is actually just equal to n. So raising a base to a power and then taking the logarithm to the same base are inverse operations, so they kind of undo each other. All right, so if we were to, this is just a proof, so if we were to do the proof, same thing we did here, you're just going to get the value of n. So that's what you're going to get. You're going to get n. Okay, now the next thing we want to do is evaluate logarithms by changing the base. So if we try to evaluate log 5 of 50, what problem are we going to encounter? Well, let's check. If I have log 5 of 50, and that is equal to v, well, 50 is equal 5 to the power of v. Well, we can't express 50 as a power of 5, right? It's going to be an uneven number, and it's going to be something that is not nice to work with. So that's the problem we're going to encounter. So choose the correct alternative. The exact value of log 5 to the power of 50 is between 1 and 5 and 2, between 2 and 2.5, or between 2.5 and 3. Well, we're actually going to have to go through and calculate this. And so in order to calculate that, what we would actually do is go, since log function in your calculator is a base of 10, we would go log 50 divided by log of 5, and I get 2.43. So that's the answer, which means that part 2 is the correct one to choose. So right now we're unable to evaluate this just by converting to exponential form, but we can calculate the logarithm using a calculator by changing the base to a base the calculator recognizes. And in this case, that's going to be base 10. Okay, so common logarithms are in base 10, and that's what I input into my calculator. So for example, log 10 of 1,000, if I just press log of my argument of 1,000, that's going to give me the answer, which is 3. And yeah, so log 1,000 is equal to 3. Now, if we convert this to exponential form, log 10 of 1,000 equal to v, well, exponential form would be 1,000 is equal to 10 to the power of v. Well, 10 to the power of v is the same, or 1,000 can be written as 10 to the power of 3. And so 3 is equal to v. And if I replace that, that's, well, log 10 of 1,000 would equal 3. Okay, so what you need to do in this next section is just use your calculator. Well, first estimate and then use your calculator in order to solve these. So what you need to type in your calculator is log 89, which is using base 10, divided by log 10. And you should get an answer of 1.95. So again, you would have to go log 89 divided by log 10. 1.949, 1.95. Okay, so we'll cover natural logarithms tomorrow in class.